In this tutorial, we'll practice using Excel functions to generate random quantities. These techniques are useful for building the probabilistic parts of a business model as input for a Monte Carlo simulation. Keep in mind that we're only covering a selection of techniques. Excel has several other functions for generating numbers from various distributions, and also by building your own formulas you can generate even more types of random quantities. Okay, let's look at number 1, where we're asked to generate a random number between 0 and 1. To do this, we use Excel's basic function for generating random numbers, the RAND function, R-A-N-D, with open parentheses after it. You just enter equals R-A-N-D with open parentheses in a cell, and the cell will display a random number between 0 and 1. Actually, it won't ever generate a 1, but it can reach 0.999999 with 15 nines after the decimal point, which is essentially 1. So let's try it. Oops. Go back to the cell here. Equals RAND and then open parentheses. 0.5662. There are a couple of important things to remember about this function. First, there's an equal probability of generating any number within the range from 0 to 1. And second, the function will generate a very large number of numbers before it repeats. So when you use it to generate random numbers, you can be confident that there will be no duplicates. The RAND function also provides the base for the second technique and some of the techniques we'll use farther down on the list. In number 2, we are asked to generate a random number between 25 and 35. To generate a random number between A and B, we use the formula A plus B minus A times RAND. So, when we are generating a number between 25 and 35, the formula would be 25 plus 35 minus 25 times RAND. Let's try it. So equals 25 plus, and then in parentheses 35 minus 25 times RAND with open parentheses after it, and hit enter. So we got a number between 25 and 35. See how the formula works? B minus A is the difference between the higher number and the lower number in the range. When we multiply that difference by RAND, we are multiplying it by a number that can be as high as 1 or as low as 0. If the RAND function gives you a 0, then B minus A times RAND is also 0, and we are left with A. If RAND gives you 1, then B minus A times RAND gives you the width of the range, which would be 10 in this case, since we're going from 25 to 35. And when you add that 10 to the lower number, 25, you get 35, which is the upper number in the range. Once you've entered a formula like these, the number displayed will change every time formulas are recalculated in your spreadsheet. On a Windows computer, you can cause all formulas to recalculate with the F9 key. Hit F9 a few times and watch the random numbers we have generated so far change. There we go. On a Mac, you might have to press the function key, capital F, small n, and then the F9 key to get it to work. In number 3, we're asked to generate an integer between A and B. So, to generate an integer within a certain range, Excel has a special function to do this called RANDBETWEEN. Its usage is simple. You just type equals RANDBETWEEN and then put the two bounds of the range within the parentheses. Note that the range is inclusive. That is, you can get either the upper or the lower bound as a result. So let's try it. We're trying to generate an integer between 1 and 100. So that would just be equals RANDBETWEEN, and in the parentheses put 1, 100. You should see an integer between 1 and 100 displayed. For number 4, we need to generate a number from a normal distribution. Perhaps in a statistics class you took, you learned how to evaluate whether or not a variable was normally distributed and how to calculate what the mean and standard deviation of the variable were. Here we're going to work in the inverse direction. We're going to generate one number at random from a normal distribution with a known mean and standard deviation. So in number 4, we're asked to generate a number from a normal distribution with a mean of 100 and a standard deviation of 15. Incidentally, IQ in a population is normally distributed with a mean of 100 and a standard deviation of 15. So think of it as generating an IQ. We use the NORM.INV function to do this. It takes 3 inputs: a percentage, a mean, and a standard deviation. What this function actually does is calculates the number from a normal distribution with a certain mean and standard deviation that some percentage of the distribution is less than, and the percentage is the percentage that's in that first input in the parentheses. When we calculate this percentage on the fly by embedding a RAND function within the inputs for the norm.inv function, we're essentially generating a number at random from the normal distribution. Let's try generating the IQ. So it's equals norm.inv, and then we use the RAND function with open parentheses to generate the percentage, and then put the mean of 100 and the standard deviation of 15, close the parentheses, and hit enter. And we've generated a number from that distribution. Now hit the F9 key to generate another one, and another one. If we kept hitting the F9 key to recalculate formulas and saved all the results, we'd have a big pile of numbers, and that pile of numbers would be normally distributed with a mean of 100 and a standard deviation of 15. For number 5, we need to generate a number from a discrete general distribution with 2 outcomes. In this example, we're generating the results of a foul shot for a player with a free throw percentage of .872. We use that free throw percentage as our best estimate of the probability that the player will make the foul shot. We use an if function for this one and an embedded RAND function. If the RAND function generates a value lower than the probability of A, which is making the shot, then we say that A occurred. Else, we say that B occurred. In this example, A stands for making the foul shot and B stands for missing the foul shot. The player has a .872 probability of making the shot, so if RAND generates a number less than .872, we say that the player made the shot. Else, we say that the player missed the shot. Why does this work? It works because the RAND function generates numbers between 0 and 1 with an equal probability of generating any number in that range. So as a consequence, there is a .872 probability that RAND will generate a number less than .872. Let's enter the formula. So it's equals if, and then embed the RAND function. If that RAND is less than .872, then put a comma. If that's true, we're going to say made it, and then another comma. What to do if false? Say missed it. And again, if you recalculate this formula over and over again, 87.2% of the time, it's going to say made it. I'm hitting the F9 key, but it's not changing much because most of the time, there's a miss. Most of the time it makes it. Okay, the last technique works in a similar way, taking advantage of the RAND function. But if there are more than two outcomes, we need to create a table and use the VLOOKUP function in a tricky way to generate the outcomes at the specified probability levels. For number 6, we need to generate a cell that says depression 3% of the time, recession 10% of the time, sluggish growth 20% of the time, growth 60% of the time, and strong growth 7% of the time. To do this, we make a table of the discrete outcomes and assign a range to each one. The ranges are contiguous, and the width of the range is equal to the probability of the outcome. I've started this table at the bottom of the spreadsheet. So let's write the outcomes and probabilities in there first. So we've got depression, and its probability is 3%, 0.03. We have sluggish growth. Its probability is, oops, I forgot recession. We have recession. Its probability is 0.10. Then we have sluggish growth. Its probability is 0.20. Let me format these so you can see them in a standard form. Then we have growth. Its probability is 0.60. And finally, strong growth. Its probability is 0.07. Now we have to get one of these outcomes. See, the numbers add up to 1. Now let's enter the ranges. The key is you always begin the range on the first row with a 0. So anytime you do this technique, the first range always begins at 0. Make the width of the range equal to the probability of the outcome for that row, and then begin the next range where the first range left off. Continue this way until the table is filled out. So we need the width of this range to be equal to that probability. So for the width to be 0.03, we have to go from 0 to 0.03. The next row starts where we left off at 0.03, and the probability on this next row, recession, is 0.10. So that means we need the range to be 0.10 wide. For that to happen, we need to go from 0.03 to 0.13. And then we take that 0.13 down here. This row needs to be a range of 0.20, so that would take us from 0.13 to 0.33, and so on, until we finish the table. Next, we generate a number with the RAND function and use the VLOOKUP function with the true option to look up the number that we generated by RAND in the table we just created. So the lookup values, we're going to generate a number with RAND and look it up in this table. And we're going to match that number against these values in the at least column and then return an outcome. Remember, key point is that VLOOKUP with the true option will match the closest value in this table that's less than or equal to the lookup value. So if RAND gives us a value of at least 0 but less than 0.03, so in this range, the closest number less than or equal to it is going to be 0. And that'll happen 3% of the time. And depression will be displayed. If RAND gives us a number between 0.03 and 0.13, which it will do 10% of the time, the closest match in the left-hand column of the lookup table that's less than or equal to that number is going to be 0.03, and recession will be displayed, and so on. So let's enter the function here. So we have a VLOOKUP, so equals VLOOKUP. We're going to look up a random number, so that's going to give us something between 0 and 1. And the table we're going to look it up in is right here. We have to make sure the at least column is on the left-hand side. And we want to make that an absolute reference. No, actually it doesn't matter here. And then when we get a match, we want to bring back what's in the third column, because that's where the outcomes are. And we want to make sure to use the true option. So mine shows growth. Now if we kept regenerating the formulas with the F9 key over and over again, we would get depression 3% of the time, recession 10% of the time, sluggish growth 20% of the time, and so on. Okay, so that ends our tutorial on how to generate random quantities in Excel. And now you have a great set of tools for implementing Monte Carlo simulations.